I'd like to say good morning to everybody. I'm going to be graphing, helping out my second farmers, and I hope I'm helping out someone there in the world today or the Caribbean region. So we have to plot a graph of image versus object size, and our range here, if you look at this, is from 0 to 15, and for object size is from 0 to 3. Okay, and like I said, always find increments that are easy for you to use. And so we're gonna start now. I'm gonna bend this paper. So we're gonna start with the x-axis. So here we have, it says all values for image size go on the y-axis, all values for object size go on the x-axis. So this is our x-axis set of values from 0 to 3, and it's already in good increments of 0.5 for us. So we just have to look for the spacing accordingly. So we could have 0.5, 1, 1.5, 2, 2.5, 3, right? And so so every two is 0.5, 1.5, 2, 2.5. So every 10 spaces again is 0.5. So every 10 spaces you keep adding 0.5. Remember, you can't just say I'm going to put whatever I want. They have to be equally spaced, and the increments must match in terms of this is 0.5, another 10 spaces you add 0.5, another 10 spaces you add 0.5, and this will be 3, and another 10 spaces will be 0.5. Okay, now we label this one object size, and you put your units. Okay, now for the y-axis, it spans from 0 to 15. So we could find enough space. Let's see. Let's go every 2. 1, 2, 3, 4, 5. And I don't think that's enough space. 6, 7, 8, 9. 9 and not 15 yet. So we're going to go every 5 spaces. We're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So yeah, so you could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So every 5 spaces is determined to be 1, and we're going to label this our image size. In centimeters. And then we could start plotting. So we know that when the object size is 0.5, it's 2.5. So each of these spaces in here, how you work it out, you minus 2 from 3. So you would say 3 minus 2, 1. Count the amount of spaces, 1, 2, 3, 4, 5. 0.2. So each space is 0.2. This is 2.2, then 2.4, then 2.6. So 0.5 must be between 2.4 and 2.6. And you put a dot and you circle it. Now when it is 1, when the object size is 1, then move up to 5. So here we have that, the 1 and 5. When the object size is 1.5, it's 7.6. So we have here 2, 4, 6. Right? When the object size is 2, it's 10. 2, it's 10. When the object size is 2.5, it is 12.6. So 2, 4, 6. And when the object size is 3, it's 15. Wait. All right, and so we're gonna find our best fit line now. Best fit line means that the line is placed equally between the points. And it looks like we might get a best fit. All right. It doesn't pass through some of the points, but that's what the best fit line is. Passes equally between the spaces. Now, to find your gradient, you want to cover it like an average of all the points you would have plotted. So you want to cover all these points. So you pick 2 points on the line, 2 random points on the line. My points might not match your points, but you always try to make sure the point that you pick is on an intersection where two lines would have crossed and not in a space like in here. You want where 2 lines would have crossed, and you look for them. You look, so I will do here, and you use different points, by the way, different types of points. So instead of the dot and the circle, you use the cross because you want to differentiate which point you are using to determine your gradient. So this is point 1 for me, and then I'm going to pick one down here where the lines cross again, and here that's one. And so this is my point 1. Actually, this could be a point 1, this could be a point 2. You're going to get the same answer. So now I'm gonna look for, so this will be y1, x1. I'm gonna look for the coordinates for this point. So this point starts at 15, so 2, 4, 6, so 15.6 centimeters. So once you have units, you want to put them back, and then the x now, down here, in between here, every 2 is 0.1. How? Again, you just minus. You just say 3.5 minus 3 equal to 0.5. Each one is 0.5. Sorry, 0.5 divided by 10 spaces. 0.05. So this is 0. This will be 0.05. You add 0.05, you get 0.1. So every 2 spaces is 0.1. So you will get 3.1, 3.2, 3.3, 3.4. Right? So where x is, if you look at it, is on the second one going from number 3, so it's 3.1 centimeters. Okay? And here now, this is a y2, and if you go across, this will give you 2 centimeters, and then x2, if you go down, this is 2 away from 0.5, so every 2, remember it was 0.1, so we're going to just minus 0.1 from 0.5 to get 0.4 centimeters. How you find the gradient? The gradient is rise over run, the difference in rise over run. So you use these same things. So it's a y1 minus y2 over x1 minus x2. 15.6 centimeters minus 2 centimeters divided by 3.1 centimeters minus 0.4 centimeters. Stick that in your calculator. So end up with in brackets 5. So our answer is 5. So 5. Now don't forget to put your lines. Don't forget to put your lines and you're good to go. So we put our line coming down and we do it perforated. Make sure it's on the line. And then we put our line going from the other point across. Alright, so you're good, and then you give your graph a title, image, size versus object, size, and you're good to go. Yay! Bye-bye.